In this tutorial, you will learn how to implement in IPKISS a 4-channel MUX based on MZI lattice filters, which shall be used in a wider circuit. The MUX is implemented by combining different 2-channel filters. Let us assume that one starts from the schematic of the 2-channel filter shown on the screen. One would have to replace the components with those present in a PDK. You can import a PDK into Canvas by loading a library and locating the IClib file associated with the PDK in the IPKISS subfolder. You can then access the list of components within the PDK and drag and drop the desired component onto your canvas. In this case, I shall replace the directional couplers with those implemented in our example PDK SciFab. After replacing the directional couplers with PDK components, one can right-click on the background and generate a code template, which provides a preliminary version of IPKISS code to implement the circuit. This code can be copied into an IDE and made parametric, which provides the designer a lot of flexibility. By writing IPKISS code in a parametric approach, one can modify the circuit by simply providing high-level specifications. In this case, I would just need to provide the central wavelength and the free spectral range, and IPKISS would synthesize the circuit for me. The delays are calculated automatically and are implemented using Manhattan connectors. By running this script, IPKISS generates the layout of the MUX circuit and runs a simulation to obtain the transmission spectrum. Upon changing the design specification, say the FSR from 20 to 10 nanometers, and rerunning the script, IPKISS would regenerate the layout and the simulation would also reflect the change in behavior. Therefore, a parametric approach allows one to freely tune the circuit to obtain a desired effect. We shall now implement a 4-channel MUX by connecting 3 2-channel MUX circuits together in the manner shown here. A parametric 4-channel MUX can be defined very easily in IPKISS. And now one can create a circuit by simply providing a high-level design specification.